My dear students, now we are going to look at Demux, which is also known as demultiplexer. So demultiplexer is reverse of your multiplexer. So as we have seen in multiplexer, what is there in the multiplexer is 2 power n inputs, then 1 output, n selection lines. So there will be inputs, of course. There will be only one output. So what we try to do is whatever is there on the input part will become output, and what is there on the output part will become input part. That becomes your demultiplexer. This we have seen with respect to mux, of course. Now, if I want to show you the general block diagram for a demultiplexer, there will be only one input. There will be 2 power n outputs. It is 1 is to 2 power n. Okay, there will be same n number of selection lines. There is also n number of selection lines. So these are the output lines, and this is input line. Okay. In multiplexer, you will find an enable input to enable the functionality of the device. Here also we will find an enable input. Okay, this enable can be active low enable, low enable, or it may be active high enable. What is active low enable? What is active high enable? That we will see now. If there is no bubble, this is called active high enable. If there is a bubble here, then it is called enable bar input. We call it as enable bar input. Active low enable is enable bar. So when active low enable is there, it is active when input is active low. It is active when input is active high. So what is meaning of that is active low is active when it is active low. Mean to say active low is active when input is active low. The meaning of that is if en bar is there, it should be 0. Similarly, active high is active when input is active high. The meaning of this is enable. Okay, enable should be equivalent to 1. When enable is 1, it is active. So this is how your enable is going to function with respect to demultiplexer as well as multiplexer, of course. Now what we are doing in demultiplexer is we are converting serial data into parallel form. What we did in this multiplexer, we have converted parallel data into serial form. So what we need to do is, if we are using parallel to serial converter at the transmitter side, and if you are doing serial to parallel at the receiver side, Rx is receiver, Tx is transmitter. In between, we will be having only one line. What I mean to say is, I am extending this output, I am connecting this to input. Now we are starting with n number of inputs, 2 power n number of inputs. I am ending with 2 power n number of outputs. 2 power n inputs, 2 power n outputs. This is the distance we are traveling. Like this is at one place, this is at another place. So we are transmitting data on only single wire. If this mux and demux is not there, let's suppose mux and demux, if they are not there, I need to what exactly? I need to have 2 power n wires, 2 power n wires, which has to be run from transmitter to receiver. So for a longer distance, we can't lay down 2 power n wires. Say for n is equals to, say for example 4. 2 power 4 is 16 wires. You have to run all 16 wires from source to destination or transmitter to receiver. So to avoid that, what we try to do is, we will convert the parallel data into serial form. On a single wire, we will transmit the data, then we will convert it back to parallel form. Okay, this is exactly the idea behind having multiplexers and demultiplexers. Okay, now once again, if you look at the enable, what is the role of enable here? This enable is used for two purposes. The purpose number one is to save power. Save the power. What is the meaning of saving the power is, whenever you are working with it, we will enable it. If you are not working, we will disable it. What is that is, if I keep enable equal to 0, then I am saving the power. Okay, power gets saved. Power saving mode, because your IC is not going to work. Okay, similarly, what I try to do is, if I take enable bar, what is enable bar? Active low input. For this, if I give 1, same you are doing power saving. It is in power saving mode. Okay, so if enable bar is low, okay, it is functioning. When enable is 1, it is functioning. This is for condition for functionality, of course, but this also useful for expanding multiplexers and demultiplexers. I can say expanding. Expanding in the sense, if you want higher order Demux from lower order, we do use, okay, enable and enable bar. Okay, what is meant by higher order demultiplexers? Higher order demultiplexers are, say for example, I have 1:2 Demux, 1:4, 1:8, 1:16. I can get 1:16 from 1:2 or 1:4 or 1:8. The way we have seen in case of multiplexers, what we did is, by using 2:1 multiplexers, we have built 8:1, or by using 4:1 multiplexers, we can build 16:1 mux. By using 16:1 mux, I can build 64:1 mux, so on and so forth. The same thing what we have seen with respect to muxes, that we are going to see with respect to demultiplexer. This is what exactly we have seen in multiplexers. So the same thing is possible in case of demultiplexers also. Okay, so this is about demultiplexer operation. Now when it look at further, okay, so what I can do is, now I will take a small demultiplexer for which we have only one input, two outputs, one selection line. Let's say it is S0. Let's say this is data in D0, which is equals to 1. I have a enable input, which exactly I am making it as 1, enable equal to 1. Active high enable. This is 1:2 Demux, and there are two outputs. Okay, let's say this is 0 and 1, output 0 and output 1. So now how exactly it functions is something like this. Say when enable is equals to 0, okay, doesn't matter S value, doesn't matter, D0 value doesn't matter. Your output is, say, let's say I0 and I1 output. So output O0 and O1. So output 0, always 0. Output 1 is also 1. Okay. So what is the meaning of this is, this is disabled. When enable is equals to 1, when enabled, when S0 is equals to 0, your output 0 is nothing but D0. When enable is equals to 1, your S your S1, when S0 is equals to 1, your output 1 becomes D0. That means what exactly happening? Either you are routing the input D0 data 0 line to output line 0 or to output line 1. So either way we are doing. What I mean to say is, if I show with a different color, either it is routed over here or it may be routed over here. Who is routing this? Is being done by S0. Okay. So this is how your Demux structure works. If I take higher order, let's say which is 1:4, we'll be having 4 output lines. There will be 1 input line, 2 selection lines, 1 enable, which I am taking it as enable bar. Now this is D0. Let's say D0 is equals to 1. Now you are going to get output line 0, output line 1, output line 2, output line 3. Now these are the selection lines S0 and S1. Okay, where S1 is MSB, S0 is LSB. Right. So from this also you can look at the operation. It's very simple. Well, enable bar is 0, it is going to function. So when S0 S1 0 0, your output O0 will be D0. For 0 1, output will be D0. For 1 0, output will be D0. For 1 1, output will be D0. So what exactly that we are trying to do is, either we are routing this to this line or to this line or to this line or to this line based on these values, based on enable condition. Once it is enabled, it is functioning. Once it is functioning, I can route the input to the outputs. Okay. So what is coming on this line is multiplex data. Let's suppose I say 1001 is coming on this line. Okay. If I change the input from 0001 1011, what is going to happen is 1 will come over here, 0 will come over here, 0 will come over here, 1 is going to come over here. Okay. This is how it is going to work.